Hello everyone, you're welcome to my series Python for All. This is Messed Up Mentors, and in this video I will be talking about writing Python packages. And so I will give you detailed explanation of how you can also create your own Python package and upload it to pypy.org, or before uploading to pypy.org you upload it to test pypy. First, to write a Python package, okay, and upload so that other programmers can use it, you need to draw up a structure of your sample project. So here you create this file structure locally on your system. First, the package you want to develop, okay, will take that parent name. For example, in my case, I want the package to be called numeric pi. You can use any name. You can call pi numeric, any name. But you must first of all ensure that no such package exists under that name on pypy.org. So I have numeric pi. And then right inside this parent folder numeric pi, you have the following files: the license file, the pi project.toml, the readme.md, the manifest.in. Okay. And then you have another subfolder called src, source. In that source, right, you have another folder. That folder bears exactly the name of your Python package. Please follow the structure. The parent folder is numeric pi. The Python package also bears numeric pi. So right inside this folder, which is domiciled in a subfolder in source, I will show you the folder structure very shortly. You have the Python init file, and then you have your module files. They can contain function or classes or a mix of both function and classes. It doesn't matter. Now, if I want another a sub package, I can create another subfolder called miscellaneous, MISC, as you can see here, and I will have also Moodle files inside it. But every time you create a sub package, there must be a Python init file also created in that subfolder. Then lastly, I have the test folder. So let's look at the folder structure. Okay, I've given you the pictorial view. Let's open it. This is my numeric pi. In numeric pi, I have given the parent folder the name numeric pi. Right in numeric pi, like I did mention to you, I have the source, test, license, manifest, pi project, readme. You see it? Right in numeric pi, I have license, pi project, readme, manifest, source, and test. Those are right in here. And if you open the license, you can see the content of the license. Okay, you can get that online, the MIT license, or any. Then the manifest NE. In my project, I may have some images, okay, or some files that I don't want to be uploaded on PyPy. I will include them here. That's why I have graphed, graphed numeric, include numeric pi. Okay, so I want to include this. I want to include the pi.toml file. I want to exclude any IPYNB files. I want to exclude temporary files that are created. And then the Pi project file, I would like to show you that now the Pi project file is also very, very important. The Pi project.toml file, there you can get this how to structure this file on python.org. But here I have the build system, okay, and then requires, I have setup tools and will backend. What backend will you be using? I have this backend, and then the project now, okay. In the project, remember you have to follow this structure strictly. I have the name, I put it in quotation, numeric pi, what version is it, authors, I put in, put the dictionary of that in a list, name, messed up mentors, email, and then description. What's the package all about? I'll give you descriptions all about numerical differentiation and integration in Python. and then the readme get to refer to the readme file domiciled in the parent folder. And then what Python version do you require? Put it there. Then classifiers, license, call the license file. What are the keywords? Then also I can now define the project URLs. Okay, how to track bugs and the homepage. All of this will be present in a Python Tommy file. And then the readme file, of course, you can open the content. You see, you give a detailed description of how to install the Python package, how to use it, and any additional information you think the users will find valuable when using your Python package. So you put it there, describe the content. You can show examples of the usages, so it also makes it easy for them to use your package. So right inside the source, you see I have, never mind, this is a temporary file that should be thrown away. So right inside the source, I have another subfolder. Now in this folder, I have it named as numeric pi. It has to bear the same name as the name of the package, which is same as also the name of the parent folder. So open again, right inside I have now my Moodle files for differentiation, for integration, like called diffpy, numeric pi. I don't want to open the content, just but I have functions or classes there. Then the neat folder file I'll open, this is, if you open it up, you can either leave it empty, but you see here I've put in all, and I'll explain what I did here. I've put in all, and I have df d2f integra. Now what I'm simply doing here is that in my files here, let's open this with Tony, the diff. You see that the diff here contains the class df, which is the derivative, the first order derivative. And I went on to define the various method. And then I have d12 right inside it. Okay, I have test d12, test underscore df, test d12, all of this. Okay, now in Integra likewise, if I open this, just open with this, I have the content integra class. Okay, and then all of that, you can learn about this in my video where I talked about classes. I will leave the link also in the description of to this video. So I have test and test here, but you notice that I have the class integra, and I have the class also here df and d2f. So in my um initpy, I simply put this, okay, and assign them to double underscore all double underscore. The idea is that if you do like people do most times, from that package import asterisk, all of these classes, okay, which are in those Moodle files, will be imported to your namespace. That's the goal behind this. Okay, but you don't need to do that. You can leave your double underscore init dot double underscore dot py file empty. Then if I want another subfolder in numeric pi, I'll simply create that as miscellaneous, MISC. So I have the folder, and right inside there, you must also drop an init file, and then the subsequent Moodle files I have square and timing. So all of these points down to the folder structure that I itemized here. This is the sequence. So you can see the main parent folder. This is also this now contains a source which contains the folder housing the modules defining the package itself. Okay, further sub modules will be housed inside that um, subfolder numeric py, and then it will also contain its own Moodle files and the init file. If I want another additional Moodle file, I simply put it again under numeric pi, okay, right inside numeric pi, and then containing its own init file. It's very important. The init.py helps Python to know where to look for each of these modules when you have created your Python package. So having finished all of these, the next thing for us is to what to build our package. So I've written my codes, I have my Moodle files containing functional classes, and I've organized my folder structure this way. What I need to do next is to build my package. So how do I build my package? I simply go here, open your terminal, or open your command prompt. First of all, if you don't have, you do Python 3 minus m pip install, and then you put build. If you don't have build already installed, you just do pip install build. If you have it already installed, you can update your build. Even code runs, and of course you can see we already have all of this installed, still running. And then I don't have a new version, so I have it fully installed. Now the next thing you will do is to move in straight into your project folder. So here I can find out my project folder. You can see the list of so I'll simply move out, and then here this is my project folder, numeric.py. So what would I do? I'll do cd and I'll go into my numeric py. I'm writing there ls. It shows me the content of numeric py, license, manifest, PyProject or toml, read, and then the folder, source, and test. So right inside this folder, what you simply do is to do Python 3 minus m, and then you build. So what it does is that it builds the distribution, okay, what I need to upload on test.py or pypy.org. So if you click build, it starts building. Okay, it's finished building. So successfully built numeric pi, okay, dash the version, okay, the tarball of that version, and also built numeric pi wheel. So let's go back to our folder. Right in here, you can see it in distribution, okay, dist. If you open, you have the tarball and the wheel of my package. So having done this, what should we do next? The next thing is that we have already built a package. We need to upload it to test.py first of all to test the package, and when we see that it's working well, then we can upload to pypy. So to upload to test.py or pypy.org, you need to first of all also install Twine. So I'll go back again and do Python 3 minus m pip install. I have Twine. You can use minus capital letter U or double dash upgrade, right? So it's going to check for new version of a new version of Twine, and it does have a new version, and then it is successfully upgraded. What's the next thing you do? The next thing is for us to what? To upload to test pypy. But for us to do that, you just pass in this command. Mind you, all of this command I'm running, I'm right inside the parent folder numeric pi, which is my project folder. So you will need to run this code. You'll be prompted for a username and a password. So before that, you need to um, go to your browser, open testpypy.org, and then you click login. If you don't have an account, you create an account and a username. And if you do have, just log in. Once you log in, it takes you here. These are previous projects that I've built and uploaded to test PyPy. But to upload a new one, what I'll simply do is to go to account settings, because you need to create, you need to come here and create this token. For username, just use double underscore token, double underscore. But for the token value, you have to specify, you know, the token value, but it starts with a prefix, pi, and then dash. So I need that token value. So all I need to do is to come here, scroll down, 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 down. Yes, here I create API token. That's where you should go to. You click on create API token. It asks you for the token name. I want the token name to be numeric pi. Okay, numeric pi. And then to ask for scope project, I will just put all projects. Of course, it throws up a caution that your API is scoped to the entire account, will have upload permission for all your current and future projects. Of course, just a warning. I'm giving you some caution. Then I'll say create token. So it's going to create the token, and I'll copy the token. Okay, click copy token, and I think and then this is how you pass in the token. So I've copied the token. I would come back here. So okay, go to my where I have my package already open in the terminal. So I'll pass the command python minus m twine upload that double dash repository test pypy distribution, okay, backward slash asterisk. What it means is that upload all the content of what you have in this distribution folder. That's what it means. So we go back there and simply do type Python 3 minus m twine, twine what? We'll do twine, twine upload repository, okay, test py. So twine upload dash dash repository, okay, and I want to upload on test py. And what else do I have? I want to upload backward slash, okay, repository, I think is it was little typo there, repo, yeah, repository, I think that is correct. I'll hit enter. You see it shows uploading, uploading, uploading. Now the reason why I have this uploaded is that I already have configured earlier when I uploaded this project, the API. So let's go back here. Let's check if it's uploaded. So all I need to do is to refresh, no, cancel this, go to my projects, and you see numeric pi is already there in my project. Previously I had 3 projects, but now numeric pi has been uploaded. So you can see how easy it is to build your project and then distribute on pypi.org, or to start with testpypi.org. Now what's the next thing we are going to do? We are going to go straight to simply what? Install this package that we have built and uploaded. So we'll simply use this command here on my terminal. I just pass that command. So I say simply type pass python 3 minus m pip install double dash index URL, passing the URL. Okay, I have it simple. And I have dash dash no dependence. Don't pass, give me dependencies, and then numeric pi. If you click that, you're going to see what is happening. It goes to the internet, of course, it's searched, and then it installs numeric pi. And what version? 0.1.0. Let's see our Python package is there. How do we run our code to check our package? We simply do from numeric pi. You can import numeric pi. You can say from numeric pi, you import, or do you import differential, okay, and also import integral. What do we have? It runs, it says, oh, cannot import differential and integral. Let's see. I think in our package, our source file, what do we have? Oh, we have diff and integral. So that's an error there. Sorry for that omission. Just import diff. If you do the wrong thing, Python throws up that error, and we run. You see that it works, and then we have imported the Moodle files there. So you must be sure of the Moodle names, and that's why you specify that in the README, so that the users know the Moodles in your Python package. Okay. Likewise, we can also do from numeric pi. Okay, the package name dot. I have a sub package miscellaneous MISC. So use a dot, and I can do import asterisk. Okay, if I run this, it says has no attribute square. Okay, also it throws up that error. If I go to my miscellaneous here, it is small letter square. Okay, and why is it throwing up this error? Go to my init folder pi, specified capital letter square. So that's where the error is coming in from. That's a subtle bug. Okay, so I'll change it back to this, and I will save and close this. If we go back there, let's see what we got. Let's go back. Let's re-execute this cell again. It throws up the same error. That was okay. Built and uploaded online. Okay, has that bug, subtle bug there. So let's take out these. Let me just do. I have square. Let's import timing. Timing. Just want to show you how it works. You can see it's working. So now I can check help on diff. Okay, it's not differential. I initially used differential, okay, but later on I just changed that it's diff, so that you don't get confused. Right. So diff. So let's run help on diff. And what do we have? It gives you the detailed explanation of what is in my Moodle file. And that will exactly execute. I did mention that in my previous video. Okay. I've already passed in comments, documentation. Okay. So it will pop up the documentation, and then it tells you the name of the numeric.df. That's the module is speaking, and then breaks down the content. Okay, the classes there, the functions there, and you know, sub and gives you examples. As long as I've detailed all of this in my doc file, okay, which I've already given that description in the Moodle file, it gives you that. Let's see help on Integra. Likewise, of course, it gives you the same thing. Help on the module integrate is numeric.integra. So this video is just a quick overview and detailed explanation how you can build your Python project and deploy it online for other users to use, either by first of all putting on testpypy.org, and when you see that it's stable, you can upload to pypy.org. With this, we have come to the end of this video. Like this video, share this video, and also if you are watching and you have not subscribed to my channel, please subscribe to my YouTube channel, Messed Up Mentors. I will see you in my next video. Bye.